Welcome to Easy Gates, Gate 22 Instrumentation Solutions. Next problem. Question number 42 based on R2R ladder network. So which happened in the morning session, easy also. And instrumentation aspirants who attempted probably the easy paper, so probably felt a little better while attempting this problem. Okay, yes, it's also based on a DAC, R2R ladder DAC. But the question is little different. Okay, yes, it is straight away playing for additional input, and instead of asking for the analog output, he went straight away for VThevenin and RThevenin of the given circuit. Okay, so let me read the statement. We have a R2R ladder DAC converting digital to analog voltage that is receiving a digital input that result in the circuit having the state as shown in figure. For this digital input, for the given digital input, the Thevenin's voltage VThevenin and Thevenin resistance R Thevenin as seen at the output nodes are. Okay, very simple. So digital logic is already given. Okay, so there is a data A, data B, data C. So data C connected to ground, data A connected to ground. That means it's a digital logic 0. This is a digital logic 0. This is a digital logic 1. So 1 means it is connected to the 4 volt. 0 means connected to. So logic 1 is 4 volt. Analog 4. Logic 0 means analog 0. That's how he played. So now for the given connection is looking for VThevenin and RThevenin. So this is where we should look for VThevenin and then RThevenin. So VThevenin is the open circuit voltage for the given 0, 1, 0 input pattern. So 0, 1, 0 is ABC. ABC 0, 1, 0 means what is the VThevenin and what is the corresponding RThevenin. RThevenin is not going to change with respect to your input, digital input, because RThevenin is always a source free resistance. You have to make all the input 0. So it's equivalent to a combination of 0, 0, 0 only. Okay, so VThevenin alone is going to differ for the circuit. So let us get into VThevenin. So this is where I'm looking for the Thevenin's potential. VThevenin is the output potential for the given combination. So this is connected to ground. This is connected to ground. So that means this 2K, 2K are in parallel. That is equal to 1K. And similarly, this is connected to the ground. Okay, so then, okay, 2K parallel is going to be 1K. That 1K will be in series with this 1K. So effectively, the resistance seen here is 2K. So this is 2K, a little play by the designer. This is 2K. And here it's open circuit. So this 1K and 2K will be in series. So that is going to be 3K. So effectively making the circuit something like this. That's where he played little. So the circuit becomes this. It is a 2K. And then we have 2K and then a 3K. So this is how he played. This is your excitation, that is 4 volt. Okay, so this is 4 volt. It's connected to 2K, and then left side you have effective equivalent of 2K, and right side you have effective equivalent of 3K. So now, okay, how we can reduce means, so we are looking for the response in the 3K. So that means we can disconnect the 3K. So we can Thevenize this further. So that is going to become a 2 volt and then a series resistance of 1K. Okay, then you connect your 3K where you want to find the response. So this is 3K and this is 1K. So that means it is 4 volt divided into 2. That means the current is going to be 2 by 4K. It is going to be 0.5 milliamps. Then 0.5 milliamps in 3K will make 1.5 volts. So straightforward, but you need to Thevenize little instead of going for a current division or potential division or finding the total impedance. This is a better way. So the VThevenin is equal to, let me check, 4. 2K, 2K, so it will be equally shared. If I disconnect 3, then it is going to be 2. R Thevenin will be equal to 1K. That's fine. So then V Thevenin is 1.5 volt for sure. Then we'll calculate R Thevenin. So R Thevenin, switch off all the inputs, including the 4 volt battery. Then this is connected to ground. That's what it means. So 0, 0, 0. So that means this 2K, 2K again parallel 1K. So that is going to be 2K, 2K again 1K. That will be in series with 1K, 1K parallel. So effectively here is going to be 2K. So 2K parallel 2K, R Thevenin is going to be 1 kilo ohm. So the answer is R Thevenin 1 kilo ohm and V Thevenin 1.5 volt. Pick the right choice. Okay, what is the mistake committed? Luckily 1.5 is not there. R Thevenin 1K is for sure. That means it has to be either 0.5 or 1 volt. Minute, let me correct the mistake. Yes, so the mistake in the VThevenin is this. I took it across and luckily it doesn't match with the given options. Okay, so what the mistake committed is this. Okay, so I took it across 3K but VThevenin is only across the 2K. So the current going through this is correct. It is 0.5 milliamps. So yes, I took it across 3K. So the current is 0.5 milliamps here as per the equivalent. So then it is going to be 0.5 into 2K. So the VThevenin is equal to 1 volt. Okay. Yes, that's a small mistake. So 1.5 is not the answer. 1 is the answer. Okay. So it's VThevenin 1 volt, RThevenin 1 kilo ohm. So the best possible answer for this problem is option C is the correct answer. And hope this is a very simple problem. Hope most of the gate aspirants connected well. Okay, and got scored in this. Okay, so thanks for watching. We'll update you with one more problem soon.